And then I will get this over. Okay. Okay, so port security, and we've talked about this a couple of times. If it's unused, turn it off. So because it's one of those things, like it's kind of like leaving a default password on something. If you leave something open and it's not being used, it just kind of gives people the opening to get in and pivot. So when they're talking about this, they're talking about layer 2 attacks because they're some of the easiest hacks to deploy, but their threats can also be mitigated with really simple common layer 2 solutions. All switch ports or interfaces should be secured before the switch is deployed for production use, and how a port is secured depends on its function. Simple method that many administrators use to help secure the network from unauthorized access is just to disable unused ports on your switch, and then navigate to each unused port and issue that shutdown command. And then it'll shut that port down if it's not being used. And then you just re-enable it by doing a no shutdown, and it brings it right back up. To configure a range of ports, you can use the interface range command. And then there's an example of that down there underneath it. Okay, mitigating MAC address table attacks. So MAC address, that's that hardware address. The simplest, most effective method to prevent MAC address table overflow attacks is to enable port security. So port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port, or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. By limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network. So this is like one of those super simple, start with the simple stuff things. This is one of the baseline things that you want to do in security to mitigate those attacks. So you enable the security by doing switch port security interface configuration command. And then in the example, you'll see the command was rejected. And that's because the port security can only be configured on manually configured access ports or manually configured trunk ports. By default, layer 2 switch ports are set to dynamic auto. Therefore, in the example, the port is configured with the switch port mode access interface configuration command. So that just shows you what it looks like when it's done wrong, and then what it does after that. You can use the show port security interface command, and that one displays the current port security settings for fast Ethernet. Notice how port security is enabled. The violation number is shut down, and how the maximum number of MAC addresses is set to 1. If a device is connected to the port, the switch will automatically add the device's MAC address as a secure MAC. In this example, no device is connected to the port. Note, if an active port is configured with the switch port security command, and the more than one device is connected to that port, the port will transition to error disabled state. Okay, after port security is enabled, the other port security specifics can be configured, and then you'll just see down here on the bottom the different configurations you can use. To set the maximum number of MAC addresses allowed on a port, there's the following command, switch port security maximum, and then you set your value. The default is 1, the maximum number of secure MAC addresses that can be configured. It depends on your type of switch and the iOS that switch uses. In this example, it's 8,192. Switch can be configured to learn about MAC addresses on a secure port in one of the 3 ways. You can manually configure it. The administrator configures a static MAC address or addresses by using the following command. And then you can do the dynamically learned. When the switch port security command is entered, the current source MAC for the device connected to the port is automatically secured, but is not added to the running configuration. If the switch is rebooted, the port will have to relearn the device's MAC address. And then there's dynamically learned sticky. And this one, the administrator can enable the switch to dynamically learn addresses and stick them to the running configuration using that command they have listed down there at the bottom. And this shows what it would look like. In this example, this one demonstrates the complete port security configuration. The administrator specifies maximum of 4 MAC addresses, manually configures 1 secure MAC, and then configures the port to dynamically learn additional secure MAC addresses up to the 4 secure MAC address maximum. And then use the show port security interface and the show port security address command to verify your configuration. That's just one of those, it's always a good idea, even if you're pretty sure you did it right, or even if you're sure you did it right. I always check everything when I'm doing something that's going to be going into a production environment, just because it's really easy if you're typing along to be like, there's a comma in here, or there's a, a lot of these commands luckily won't run without the correct syntax, but every once in a while you can type something in incorrectly, like the wrong number, or you can transverse numbers. And if you don't check your work to see how everything's working and verify, you just lost how many hours, and then you have to go back and be like, okay, now how did I mess this up, when you could have just checked your work. Port security aging. Port security aging can be used to set the aging time for static and dynamic secure addresses on a port. And 2 types of aging are supported per port. There's absolute and inactivity. Absolutes, the secure addresses on the port are deleted after the specific aging time. And inactivity, the secure addresses on the port are deleted if they are inactive for a specific time. So that's that one where you manually, it's kind of the same that we were talking about for DHCP. It's a similar mechanic where you put in your number where it's supposed to just basically time out on whatever aging time or inactivity time, and then it'll get booted. Use aging to remove secure MAC addresses on a secure port without manually deleting the existing secure MAC addresses. Aging of statically configured, can you tell I've been reading a lot? Configured secure addresses can be enabled or disabled on a per port basis. And then you use that switch port security aging command to enable or disable static aging for the secure port, or to set the aging time or type. And you can see that down on the bottom, the switch port security aging, and then you'll see the static time type, and then it's got your other options down there too. And this is an example of what that would look like. So in the example, it shows your administrator configuring an aging type to 10 minutes, and then the show port security command confirms your changes. So you can see aging time 10 minutes, aging type, inactivity, and that's what you should be when you go and check that. Okay, I know I have a bunch of things that have been thrown at you so far. Is this making sense? It's similar methods with slightly different wording on a lot of this. So hopefully it's making sense to everybody. Yeah, pretty much that's pretty much this whole program, knowledge by the fire hose. They really should just use that as our tagline. But yeah, you should be seeing a lot of these in the labs. This should just be going over what you guys have already seen, a lot of this. Okay, so there's port security violation modes. If a MAC address of a device attached to a port differs from the list of secure addresses, then a port violation occurs and the port enters the error disabled state. To set the port security violation mode, use the following command, and then you'll see that switch port security violation, and then you have the shutdown, restrict, or protect. And then on this table, it shows you what the shutdown, restrict, or protect do. So if you do the shutdown, the port transitions into the error disabled state immediately, turns off the port LED and sends a syslog message. It increments the violation counter when a secure port is in the error disabled state, and an administrator must re-enable it by entering the shutdown and no shutdown commands. The port for restrict, the port drops packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. This mode causes the security violation counter to increment and generates a syslog message. And then protect. This is the least secure of the security violation modes. The port drops packets with unknown MAC source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. And this is the reason that it's least secure. There are no syslog messages sent. So this example, this shows the administrator changing the secure violation to restrict, and then the output of show port security interface command confirms that the change has been made. And you can see the enable secure shutdown violation mode restrict, and that's what you should see after you set that up at the top. Okay, ports in an error disabled state. When a port is shut down and placed in an error disabled state, no traffic is sent or received on that port. A series of port security related messages display on the console as shown in the following example. Note the port protocol and link statuses are changed to down and the port LED is turned off. And then you'll see those down there. There's the disable P-secure violation error detected, and you'll see those pop up on your messages to give you to let you know that there are problems. On this one, it shows the show interface command identifies the port status as error disabled, and the output of the show port security interface command now shows the port status as secure shutdown. The security violation counter increments by 1, and the administrator should determine what caused the security violation if an unauthorized device is connected to a secure port. The security threat is eliminated before re-enabling the port. So basically, you don't want to re-enable the port if you don't know why you're getting those error messages. And a lot of the times on these, with specific like physical ports, it's because someone tried to plug something into the wrong port, or because someone is trying to physically access network equipment they should not be trying to access. And then to re-enable the port, use the shutdown, and then it shuts down and takes it out of that error disabled state, and then you can bring the no shutdown command on, and it brings it back up out of an error disabled state. After, then you can verifying port security after configuring port security on a switch. Check each interface to verify that the port security is set correctly, and check to ensure that static MAC addresses have been configured correctly. To display port security settings for the switch, use the show port security command. And that example on the right indicates that all 24 interfaces are configured with the switch port security command because the maximum allowed is 1 and the violation mode is shut down. No devices are connected, therefore the current ADR count is 0 for each interface. And this one's the use show port security interface. And this one shows you the details and shows your secure up, violation mode shutdown, and secure static address aging is disabled. So those are the things that you should be seeing after what I was talking about. To verify MAC addresses are, quote, sticking to the configuration, use the show run command that was on the right, and you'll see the show run pipe begin interface, and then you can see port security MAC address sticky, and then you can see there's one down there on the bottom. To display all secure MAC addresses that are manually configured or dynamically learned on a switch interface, use the show port security address command as shown in the example. So show port security address, and this one pops up the secure MAC address table. So you see that the MAC address on the left, and then on the right next to it, you'll see secure dynamic, secure sticky, and it'll tell you, just exactly how it's configured. Okay, mitigation of VLAN attacks. Before I start that, does that all make sense to you guys? It's basically the same stuff that we've been going over, just here's how you do it, here's the command that you need to do it. Okay. So a VLAN hopping attack can be launched in one of three ways. You can spoof the DTP messages from the attacking host to cause the switch to enter trunking mode. From here, the attacker can send traffic tagged with target VLAN, and the switch then delivers the packet to the destination. Introducing a rogue switch and enabling a trunk, or you can use, there are devices that you can create that look like a rogue switch, but they're not actually a rogue switch. The attacker can then access all the VLANs on the victim switch from the rogue switch. Another type of VLAN hopping attack is a double tagging or double encapsulated attack. This attack takes advantage of the way hardware is on most switches operates. Okay, so this is just showing how you do that within the switch port mode. So to disable DTP, which is auto trunking, negotiations on non-trunking ports, you do that switch port mode and just make sure that you turn, just like I was talking about, turn off things that you don't need. A lot of the times, if it says auto and it's not something that you're actively using, there's going to be some sort of attack based around that eventually. So I always try to make sure to keep up with what type of auto configurations are on, like if I'm working with like a network engineer or something, I try to keep abreast of what type of network auto configurations we're using. Sometimes there's just way too many, and you have to look at a lot of times they'll have like a manual with all their stuff on there, and it's just a good idea to take a look at that and go, hey, are you aware that this auto blah blah can be attacked by, because a lot of times just regular network people are aware of some security, but not every piece of security, because they're not security specialists, they're network specialists. So disable your unused ports and put them in unused VLAN. Manually enable the trunk link on a trunking port by using the switch port mode trunk command. Disable DTP, which is your auto trunking, negotiations on trunking ports by using the switch port negotiate command. Set the native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN and then number command. And you can see all that over in that example on the right. DHCP attacks. Okay. The goal of a DHCP starvation attack is to use an attack tool like Gobbler to create a denial of service for connecting clients. Recall that DHCP starvation attacks can be effectively mitigated by using port security, because Gobbler uses unique source MAC addresses for each DHCP request sent. However, mitigating DHCP spoofing attacks requires more protection. It's actually DHCP spoofing is a fairly common attack that you're going to see on pretty much any network. Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet address in the DHCP payload. This would render port security ineffective because the source MAC would be legitimate. DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted ports. Okay, so what is DHCP snooping? This filters DHCP messages and rate limits DHCP traffic on untrusted ports. Devices under administrative control, switches, routers, and servers are trusted sources. Trusted interfaces like trunk links and server ports must be explicitly configured as trusted, and devices outside the network and all access ports are generally treated as untrusted sources. A DHCP table is built that includes the source MAC address of a device on an untrusted port and the IP address assigned by the DHCP server to that device. The MAC address and IP address are bound together. Therefore, this table is called the DHCP snooping binding table. Okay, here are some steps for implementing DHCP snooping. So enable DHCP snooping by using the IP DHCP snooping global configuration command. On trusted ports, use the IP DH snooping trust interface configuration command. On untrusted interfaces, limit the number of DHCP discovery messages that can be received using the IP DHCP snooping limit rate packets per second interface configuration command. Enable DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping VLAN global configuration command. So on step 3, does anyone have an idea why you would want to put a limit rate on those discovery messages? So do many of you know? Yes, exactly. So DOS attacks or denial of service attacks, there are several different ways to do that. And one of those is you basically just flood whatever it is that you're going after with a bunch of different messages. So if you don't set your limit, you can flood with a DHCP discovery message, and then it just overwhelms it. And that's why they have the limit rate set on that. Okay, so refer to the DHCP snooping sample topology with the trusted and untrusted ports. So DHCP snooping is first enabled on S1. The upstream interface to the DHCP server is explicitly trusted. F05 to F024 are untrusted and are therefore rate limited to 6 packets per second. And finally, DHCP snooping is enabled on VLANs 5, 10, 50, 51, and 52. And you can see that all in the little window on the side for the commands. And purple square is trusted, and red circle is untrusted. Yes, all the packets belong to us. For more snooping configuration, use the show IP DHCP snooping privileged exec command, and that verifies your DHCP snooping settings. And then use the show IP DHCP snooping binding command to view the clients that have received DHCP information. The note on there is DHCP snooping is also required by dynamic ARP inspection. So if they're going to be using that, it's also used. And then you can see over here on the right in the example that it has your show IP DHCP snooping, and then it says it's configured, and then what's on, which ones is the operational ones on, and it's got everything over in that there. ARP attacks. Okay. In a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. So dynamic ARP inspection requires DHCP snooping and helps prevent ARP attacks by not relaying invalid or gratuitous ARP replies out to other ports in the same VLAN, intercepting all ARP requests and replies on untrusted ports, verifying each intercepted packet for all valid IP to MAC bindings, dropping and logging ARP replies coming from invalid to prevent ARP poisoning, error disabling the interface if the configured DIA or DAI number of ARP packets is exceeded. So again, we have another one of those where they set a limit on packets too. So to mitigate, so DAA implementation guidelines, to mitigate the chances of ARP spoofing and ARP poisoning, follow the implementation guidelines, enable DHCP snooping globally, enable DHCP snooping on selected VLANs, enable DAI on selected VLANs, configure trusted interfaces for DHCP snooping and ARP inspection. It is generally advisable to configure all access switch ports as untrusted and to configure all uplink ports that are connected to other switches as trusted. For me, one of the best ways to remember this is and one of the network administrators I used to work with would configure anything that he knew wasn't going to be used as untrusted, and then he would switch it over to trusted if he was going to be enabling it later. So in the previous topology, S1 is connecting to 2 users on VLAN 10. DAI will be configured to mitigate against ARP spoofing and ARP poisoning attacks. DHCP snooping is enabled because DAI requires the DHCP snooping binding table to operate. Next, DHCP snooping and ARP inspection are enabled for PCs on VLAN 10. The uplink port to the router is trusted and therefore is configured as trusted for DHCP snooping and ARP inspection. So you'll see the little commands out there on the example. DAI can also be configured to check for both destination or source MAC and IP addresses. Destination MAC checks the destination MAC address in the Ethernet header against the target MAC address in ARP body. Source MAC checks the MAC address in the Ethernet header against the sender MAC address in the ARP body, and IP address checks the ARP body for invalid and unexpected IP addresses, including 000, 0, and all of the 255, and all IP multicast addresses. So basically, it's just checking for things that it knows are going to be invalid. The IP ARP inspection validate global configuration command is used to configure DAI to drop ARP packets when the IP addresses are invalid. It can be used when MAC addresses in the body of ARP packets do not match the addresses that are specified in the Ethernet header. Notice in the following example how only one command can be configured. Therefore, entering multiple IP ARP inspection validate commands overwrites the previous command. So remember that, save yourself some time because you're just going to be overwriting everything. To include more than one validation method, enter them on the same command line as shown in the output. So you'll see they tried the one where they were overwriting, and then you can see how on the bottom it's got like everything listed out that they want. Okay. Mitigating STP attacks. Every time I see that, I think of STP oil for some reason. Portfast and BPDU guard. Recall the network attackers can manipulate the spanning tree protocol, which is STP, to conduct an attack by spoofing the root bridge and changing the topology of a network. To mitigate STP attacks, use Portfast and Bridge Protocol Data Unit, or BPDU guard. Portfast immediately brings a port to the forwarding state from a blocking state, bypassing listening and learning states. Apply to all end user access ports. BPDU guard immediately error disables a port that receives a BPDU. Like Portfast, BPDU guard should only be configured on interfaces attached to end devices. So Portfast bypasses the STP listening and learning states to minimize the time that access ports must wait for STP to converge. Only enable Portfast on access ports. Portfast on interswitch links can create a spanning tree loop. Portfast can be enabled on an interface using spanning tree Portfast interface configuration command, or globally using the spanning tree Portfast default. global configuration command to enable port fast on all access ports. And you see that over in the right, the example of what that would look like when you enter those commands in. To verify whether port fast is enabled globally, you can use either show running config pipe begin span command or show span -tree summary command. To verify if port fast is enabled an interface, use show running config interface type number command. The show spanning tree interface type number detail command can also be used for verification. Configuring BPDU guard, an access port could receive an unexpected BPDUs accidentally or because a user connected an unauthorized switch to the access port. If a BPDU is received on a BPDU guard enabled access port, the port is put into our favorite old error disabled state. This means the port is shut down and must be manually re-enabled or automatically covered through the error disable recovery cause P secure violation global command. On an interface, use the span tree BPDU guard enable interface configuration command, and then globally, the span tree port fast BPDU default global configuration command. And then you'll see those over in the right. Okay. This is just what we covered. Okay. So yesterday and today were just Cisco, so they were fairly short. Tomorrow is our weekly ethics discussion. Before I let you guys go, what, if any, do you guys have any questions, or is there any anything over the last 2 weeks that you guys have had any problems with or questions on, or is there anything you need a demonstration on, or anything you need me to look a video up?
I don't know if anyone else has been having this issue, but it seems like the link on Blackboard to Cengage is giving me issues.
Yeah, no, nobody at all. Other than that, is there anyone having any problems? Yeah, I think we're all just having the same kind of, it's spring and none of us wants to be inside problems. Yeah, it was a good, you got me. Yeah, I could see that. Yeah. I hope if you get to, hope you get to go have a nice bike ride somewhere. And it's really nice here. Hopefully you guys it's been like 60s all week. So
Didn't you guys just get like snow dumped on you?
we did, and then it immediately turned around and was like, have some 60s. So at least it melted off, but Idaho weather, gotta love it. As long as it stays in the mountains, I'm fine with that. Like 40s and 60s, yeah. Okay, so it looks like everyone's good.